the 12th one, that is y equal to fx is equal to x to the power of uh, 1 upon 2 to the power 2n minus 1. That is, I'm talking about when n equal to 1, we have y equal to x to the power of 1 by 3 cube root of x. That is, this is cube root of x. Now n equal to 2, y equal to x to the power of 1 upon 5. That is the fifth root of x, the fifth root of x, and n equal to 3, so on and so forth. This is 1 upon 7. This is the seventh root of x, and so on and so forth. The thing is this: how do I draw this graph now? How do I draw this graph? Very simple. I have already shown you how to draw 1 upon the cube root of a graph. Now let me take some space. I need not this space. I need this space somewhere. I will take the space here. Now this is your y-axis, this is your x-axis. This is x and this is your y. Now you know that this graph, this 1 upon x graph goes like this. See, 1 upon x cube graph goes like this, something like this it goes. I showed you. This is the cube root graph. This is the cube root graph. Now I'll take the other color to show you that this graph, this way it will go. You will see like this. It will go like this and it will come like this. This is the fifth root. This is the fifth root. This is the fifth root. My graph drawing is bit not that good. Wait a minute. Let me redraw the structure again. Let me redraw the structure again. Wait a minute. This way, and this way. Yes, this is the fifth root. This is the fifth root in yellow color. The fifth root. That is this thing. Now I'll draw the seventh root for you with a different color. This will go like this, and this will go like this, and will come like this. This is the seventh root. The blue color is the seventh root of x. This is the way you will draw these graphs. Now you understood. Now the domain and range would be same. So I just copy that domain and range for you. Just a minute. Let me copy that domain and range for you. For what was for your cube root graph. Wait, this is your, no, not this, not this. This is not this. Wait a minute. The cube root graph. Wait a minute. Where did I draw it? I'll just copy that domain and range for you. No issue. Yes, here it is. Not this. Where did I draw it? Yes, this is not this also. The cubic cube root graph here. Yes, here it is. Now you can see this was the cubic graph, the white color, the yellow color was the cube root graph. I'll just copy the domain and range of this cube root graph. I'll just copy this thing and I'll paste there. So my work would be over. Now let me come down. Let me come down. Yes, here. Let me copy this exactly here. Paste it exactly here. Okay, fine. Now here again, I'll do some corrections for you. This, okay, and the rest remains the same. The domain and range remains the same as it was happening for the cube root graph. Now we will come to some very good functions which will help you solve the problems of limit, continuity, differentiability very easily, very easily. I think 13th one. This is the 13th one, and this is our known as modulus function. Modulus function. Shortcut is mod function. Mod function, short. Short is mod function. Remember, I'm writing the general formula first, and then x minus a mod is equal to x minus a for x greater than equal to a, and minus x minus a for x less than a. And the graph of this function is like this. This is your x-axis, this is your y-axis, this is the point A, and there are two lines like this. So with this point, with this graph in your mind, if the limit is asked at the point A, you will say the limit is there. Then the continuity is there. Yes, the continuity is there. Now they will ask for differentiability at the point A. You will say no, it is not differentiable at the point A because there are two tangents. One is this, the other is this tangent can be drawn. So this is not differentiable. See, limit will hold, limit will hold, limit and continuity will hold. Continuity will hold here. Limit and continuity will hold. Later on, I'll tell you how, why, how, and what is the way to check that. But I'm telling you, just by looking at the function, you can tell that the limit and continuity will hold, but but it is not differentiable. But it is not differentiable at A. Differentiable at x equal to A. This is the point x equal to A. This is the point x equal to A. Now I'll make you understand what, give you 2-3 examples in this so that you understand. And of course, now you see in this case, very simple. If you look at the picture, for the domain, you can take any point on the x-axis. For the domain, you can take any point on the x-axis, so it is R, right? And the range would be from, it will be R plus to union, R plus union 0, that is from your this, from your 0 will be included to infinity. Now let me take some examples and make you understand how to do this. Now let me take some examples to make you understand this this concept of modulus function. This concept of modulus function, let me explain you. Now see, let me take some space. Yes. Now the first example, example number 1, example 1. Suppose I take x minus 0. That means I'm talking about mod x. But let me show you what was my formula. Yes, let me keep the formula there. Instead of a, you have 0. Instead of a, you have 0. Now, so this can be written as x minus 0. You don't write. You do not write x minus 0. You can just write like that only. Yes. X greater than equal to 0 and minus x for x less than 0. So the graph of this function is at the point 0 you have these two lines. See, very simple. Again, this is not differentiable. Let me put some line here. So this note, let me put the note in some sort of a box. Yes, this box I have put the note in. Now it is not the limit continuity holds, but it is continuous. The limit holds at 0, but it is not differentiable at x equal to 0. See? Now let me take another one. Now let me take another one. Instead of a, now the second example. Wait a minute. Let me take the second example. Example number 2. Now let me take x minus 1. I am taking a equal to 1. I am taking here a equal to 1. Right? So this becomes x minus 1 for x greater than equal to 1 and equal to minus x minus 1 for x less than 1. Now let me draw this. This is 1 is here. Now again I will have this type of picture. Now let me take another example. Example number 3. Now instead of a minus plus 1, I'll take say minus 1, or I can take minus 2, whatever you feel like. I've taken this. So x minus of minus 1, this will behave like x plus 1 and this will behave like mod x plus 1, which is equal to x plus 1 for x greater than equal to minus 1 and minus x minus 1 x plus 1 for x. Let me rewrite it. Wait, sorry. Let me rewrite this question. X plus 1 for x less than minus 1. Now how does it work? I'll take all the 3 examples again, and how this is minus 1. This goes like this goes like this. This is the graph. Now how does this work? See, how does this work? How does this work? This one, or you take this one, or you take this one. Or you take this one. How do they work? Let me show you. Wait a minute, let me show you. Now let's take the first example, the first one, that is mod x equal to x and for x greater than equal to 0 and minus x for x less than 0. See, mod function always gives positive value. Mod function, let me write in short, not modulus function, let me write in short. Mod function always gives, always gives positive value. How? Always gives positive value. Positive value. Always gives positive value. How? See. Suppose I take x equal to 5. The mod of 5 will give me 5 because 5 is greater than 0. I will take this part of the function. Right? Now I take x equal to minus 5. The mod of minus 5, because minus 5 is less than 0, I'll take this part of the function. Wait, let me rub this. Now I'll take this part of the function. I'll take this part of the function. I'm talking about this part of the function. That is minus of minus 5. Again, it will give me plus 5. I hope you understood this for mod, for the simple mod function, this mod x. Now let's understand for mod x equal to, minus 1. I had this, sorry, mod x minus 1. Let me understand for this one. Now see, I had this as x minus 1, and this was x greater than equal to 1, and minus x minus 1 for x less than 1. मतलब x mod x plus x minus 1 के लिए तुमको लिखना पड़ेगा x minus 1 और minus x minus 1. अगर x ग्रेटर देन 1 इक्वल टू 1 है तो ये वाला लिखना पड़ेगा, और x अगर 1 से कम है तो फिर ये वाला लिखना पड़ेगा. लो, लेट अस सी. मैं लेता हूं x इक्वल टू 2. 2 इज ऑफ कोर्स ग्रेटर देन 1. 2 1 से बड़ा होता है, तो मैं ऊपर वाला फंक्शन लूंगा. सो 2 minus 1 is nothing but 2 minus 1, and this is 1. Done. अब मैं लेता हूं x equal to 0. 0 लेता हूं. 0 1 से तो छोटा होता है ना, तो I will now take, अब मैं ये वाला, now I will take, now see, 2 is greater than, sorry, 2 is greater than 1, so I'll take this function. 2 minus 1, you will get 2 minus 1 and 1. Done. Now let's remove them. Now let's take x equal to 0. 0 is less than 1. 0 1 से कम होता है, तो आई विल टेक दिस फंक्शन. मैं ये वाला फंक्शन लूंगा. तो 0 minus 1 is equal to minus of 0 minus 1 is minus minus 1, and I'll get 1. See, it is giving positive value. Let me take x equal to say minus 3. Minus 3, अगर मैं minus 3 लेता हूं तो भी 1 से कम है, तो I'll take this function. मैं ये फंक्शन लूंगा. Now you see what happens. Minus 3 minus 1 is, now you'll take this function. Minus minus 3 minus minus 3 minus 1. This is minus minus 4, and this will give me plus 4. Have you understood? समझ में आया कैसे ये प्लस आता है, देता है. अब लेते हैं, now let's take the next the example. x plus 1 वाला केस लेते हैं. x1 वाला केस कैसे था? x plus 1 for x greater than equal to minus 1, and minus x plus 1 for x less than minus 1. अगर मैं एग्जांपल लेता हूं माइनस 1 से बड़ा कोई भी एग्जांपल ले लो, 0. माइनस 1 से बड़ा कोई भी एग्जांपल ले लो, 0. 0 plus 1, तो 0 0 is greater than minus 1. I will select this function. 0 1 minus 1 से बड़ा होता है, तो मैं ये वाला फंक्शन लूंगा, and I will get 0 plus 1, and this I'll get as 1. Done. अब मैं लेता हूं x equal to minus 2. minus 2 minus 1 से छोटा होता है. minus 2 is less than minus 1. So now I will select, wait, I will select this function. I will select this function. मैं फिर ये वाला function select करूंगा. So what I'll get? minus 2 plus 1 mod is equal to minus, I'll select this function. I'll take minus 2 plus 1, and this will be minus minus 1, and I'll get plus 1. See, this is the way. This is the way how you select the, which one to select. कौन सा select करना है? ये वाला select करना है, ये वाला select करना, depend करता है कि कौन सा value लिया गया है. It depends. You want to select this or you want to select it. Depends on this or this value. This value you have selected. The value you have selected. I hope you have understood this function, mod function. Now let us understand another function called the Signum function. I need to think what is the number of that function. Wait, let me write down the number. 13th or 14th? This is 13th. Oh, that will be 14th now. Now we will have 14th function. The 14th function, very good function, Signum function. Signum function, shortcut. This is also known as, wait a minute, let me write it down. y equal to SGNX, Signum function of x. This is nothing but, let me use this now, mod x by x, then 0. This is, or you may write this way also, or you can write this way also. Both ways, I'll prefer this. You can write this way also, I will prefer this way. So what happens now? You see, mod x has two things: for x greater than or equal to 0, and minus x for x less than 0. Now I will use this concept now. First, for x greater than 0, now I'll break this. Wait a minute. I'll break this. Wait, I will break this. Now, y equal to signum x is equal to, jab signum x, this will be x upon x for x greater than 0. For this is for x not equal to 0, and this is for x equal to 0. Now, this will be, no, wait a minute. X is equal to 0. That's right. Now, for x equal to 0, this will be 0 for x equal to 0, and minus x by x for x less than 0. So this will give me this thing. This thing will give me, this whole thing will give me, and this is fixed, always. Let me keep it here. ये हर समय फिक्स्ड ही रहता है. साइन सिग्नम एक्स की वैल्यू ये देता है, this gives 1, cut this and cut this, you will get -1 here and you will get +1 here. 1 for x greater than 0, 0 for x equal to 0, and -1 for x less than 0. This is always fixed. You don't need to change. That means the domain of this function is, I'll draw the graph. Wait, domain of this function is, domain is the complete real line. You can take x greater than 0, less than 0, equal to 0, whatever. That is minus infinity to infinity. But the range has only 3 points. See, range has, what are the points? -1, comma, this is not an interval, 1, and this is a set. This is a set. See, every interval is a set, but every set is not an interval. Keep this thing in your mind. This is a set of points. -1, 0, 1. This is not an interval. Not an interval, but a set. This is not a interval, not an interval, not an interval, but a set, And let me write one thing very clearly. One more word from here. Then I'll draw the graph for this. The idea is, let me have it here, because I have to draw the graph also. Wait, yes. So every interval is a set, basically, an infinite uncountable set, basically, is a set. But every set is not an interval, but every set is not an interval. Keep this thing in your mind always, this point. Now let's draw the graph of this. Let's draw the graph. Very simple. Let me write down the function again for you all. Sine signum x, you got what? You got 1, you got 0, you got -1 for x greater than 0, and for x equal to 0, you got this point, and for x less than 0, you got this point. Let us now draw the graph. This is your x-axis, the complete domain. Now this is your y-axis. At 0, it is 0. Just you mark it like this. But at just more than 0, it is always 1. That's why I'm making a, wait, let me do with the different color so that you understand. I'm doing this. This is the point 1, but it is not here. So the complete line is like this. Similarly, this is +1, and this point is -1, and you draw like this, straight in this direction, straight line. So this is the graph of this function. I told you the domain and range also of this function. Now come to a very good function, another very good function, and you will need these functions you will need while solving limit, continuity and differentiability. Once the idea of these functions is clear, एक बार ये idea clear हो जाए ना function का, फिर limit, continuity, differentiability is not a very big problem for you. Especially those people who didn't have maths in 11th and 12th, not very big problem. Now see this. I am doing, which number is this? Wait, I always forget the number. Wait, I think 14 or 15. Wait, just let me check which number. Wait a minute. This is 14, now 15. Yes, we are talking about 15. Greatest integer function. Greatest integer function. greatest integer function, also called the floor function shortcut. Floor. I will use the word floor function. See, this is written as y is equal to fx as fx. This way it is written. This way, floor function. Floor function. This is the way it is written. This is the way it is written, floor function. That means you have to select an integer which is the greatest integer smaller than x. Greatest integer smaller than this x. Greatest integer smaller than x. Greatest integer smaller than x. Smaller than this x I'm talking about. Take an example first. What to do? Understand it more clearly. You draw a ladder. This is your 0. This is your let's say 1. This is your -1. This is your ladder is -2. This ladder is now 2. Now this way it is going up and this way it is going down. I hope you have understood. एक ladder बनाओ, वहां पे 0 लिखो, 1 लिखो, 2 लिखो, -1 -2 लिखो. अब देखो, अगर let me draw it little big. Let me make it little big. Wait a minute. Let me make it little big. Yes. Now see what happens is. अब देखो क्या होता है. Now the point is, अगर मैं पहले समझ लो इस ladder से, फिर मैं यहाँ example से समझाऊंगा. First understand from the ladder, then I'll make you understand with an example. Suppose my point is here. This is floor function. Remember, this is called the floor function. Point is here. Between 1 and 2, it will go to 1. It is between 1 and 0. It will go to 0. It is between 0 and -1. So it will come -1. Between -1 and -2, it will come to -2 because it is coming to the floor. ये floor है. ये floor पे आएगा. जो अगर 1 और 2 के बीच में है तो 1 में आएगा. 0 और 1 के बीच में है तो 0 में आएगा. -1 और 0 के बीच में है तो -1 में आएगा. -2 और -1 के बीच में आएगा तो -2 में आएगा. So this is known as floor function or the greatest integer function. अब एग्जांपल देखो, समझ में बहुत जल्दी आएगा. मैं लेता हूं 2 का तो 2 ही मिलेगा. For 2 I'll get 2. Let me take 2 point say with this ladder I'll do. No, wait. Let me take 1.5. Let me take 1.5. It is greater than 1, but between 1 and 2, 1 और 2 के बीच में है, so सीधा 1 देगा ये आंसर. सीधा 1. अब लो 0.75. 0.75 ये है. This 0.75 is in between 1 and 0. ये 0.75 1 और 0 के बीच में, आंसर सीधा देगा फ्लोर पे आएगा. इस वाले 0 के फ्लोर पे आएगा. अब लो -0.75. अब लैडर सामने रहेगा ना तो बहुत आसान पड़ता है. 0 और -1 के बीच में है, सीधा -1 आंसर देगा. सीधा -1. एंड -1 और -2 के बीच में देखो, टेक -1.5. तो दिस इज गोइंग टू गिव यू -1 एंड -2. ये इसके बीच में है, कहीं यहाँ पे है, सीधा फ्लोर पे इट विल कम डाउन टू द फ्लोर. दैट इज ये सीधा फ्लोर पे आएगा एंड गिव यू -2. ये -2 देगा. आई होप यू हैव अंडरस्टूड. नाउ let's write down the complete theory for this. Fx is equal to y equal to fx, greatest integer function x. Now let me write down. For x between 0 to 1, for 1 to x less than 2, 2 to between 2 included है, 3 included नहीं है. 2 is included, 3 is not included. 1 is included, 2 is not included. 0 is included. Wait a minute. Am I doing? Yes. I'm going up now. And this is now your 0 is not included, and this is -1. Now -1 is not included, but -2 is included. So this will give me value 0. This will give me value 1, 2, -1 and -2. And this way and that way. देखो 1 और 2 के बीच में है तो 1 देगा. 2 और 3 के बीच में है तो 2 देगा. फ्लोर में देगा, नीचे की तरफ आएगा. -1 और 0 के बीच में है तो -1 देगा. 2 और -1 के बीच में है तो -2 में जाएगा. दिस इज द वे इट इज. दिस इज द वे. और इसका ग्राफ वेरी सिंपल. मैं दो बना देता हूँ. देखो, आई मेक 2. ओके, वेट, सॉरी. दिस विल आई हैव टू कीप दिस पिक्चर in front of me and make the graph here. Now see, what I do is that, sorry, I don't know why this has come. Now see. Now this is your x-axis, this is your y-axis, this is my 0. Let me take my 1, let me take my 2, yes, and let me take my 3. Let me take my 3 here. Similarly, let me take -1 and let me take -2. See, at 0, between 0 and 1, it is always 0. Between 0 and 1, it is always 0 but never 1. So let me use a different color. It is always this, but it will never come to 1. So you leave it like this. Between 1 and 2, it is always 1. So this is 1. Let me write, this is 2. This is -1 and this is -2. Now see, between जब ये 0 और 1 के बीच में रहेगा तो 0 ही रहेगा, तो कभी 1 नहीं आएगा, तो इससे ये ऐसे करके काट दिया जाता है. अब now it is between 1 and 2. Between 1 and 2, it will come to 1 but never go to 2. ये 1 यहाँ पे है, coordinately देखो, ये the 1 is here and it will not go to 2 like this. Now similarly for 2, it is somewhere here. Between 2 and 3, it will go like this. And in this case, between -1 to 0, -1 to 0, I should have written this -1 and -2 this side. Then things would have been easier. Wait. Let me write it this side. This is -1 and this is my -2. -2. Now see, what I'll do is that between -1 and 0, between -1 and 0, I'm talking this line. This is always -1. This is always -1. So it will start from here and it will not touch this part. Similarly, for -2, just the this mouth will see. What is happening is this: the direction of the mouth remains the same everywhere. -2 and -1, it is -2. -2 and -1, it is -2. So you have -2. Now I have to draw -3 also here somewhere. Wait a minute. This is, wait. Let me draw the picture here. This is -2. This somewhere, let us say, this is somewhere, -3 is somewhere here. I'm drawing -3 here, right? So between -2 and -1, it is -2. So here it is. Okay, even if I don't draw -3, it doesn't matter. I'm not drawing, leave it. Let me do it with this only. -2, -1, it is -2. So you will draw this. It will never be -1. So let me draw it this way. Start from here, come till here, leave this line, leave this line. This is the way you have to draw. It's a bit complicated. You do a little bit of practice and it will be fine. Now this is over. Now we will understand some more important part. Now this was the greatest integer function and I think it was 15 number. The point is I forget the numbers. I think this is the 15th number. Yes, now the 16th number. We are going to go for the 16th number. Now see, we will go for the 16th number. Let me pull it a little bit more up. Yes, 16th number. The 16th number is the least integer function. Least integer function. That means I'm talking about the least integer function. That means I'm talking about ceiling function. Ceiling function. वो floor function था, ये ceiling function है. This is the difference. Now see how to write this one. Y equal to fx. Now you will draw like this. That means वो था greatest integer function less than x. यहाँ पे greatest integer function nearest to this is that was the this is the least integer function. Let me draw it for you. Here it is. Let me draw the ladder for you again. This is 2, this is 1, this is 0, this is -1 and this is -2. ये ऐसे है. Suppose point यहाँ है. The point is somewhere here. The point is somewhere here. Now it will go to the ceiling. Between 1 and 2 it will go to 2. Between 0 and 1 it will go to 1. Between 0 and minus 1 it will go to 0. Between minus 1 and minus 2 it will go to this. This is the ceiling function. It will go to the ceiling. छत पे जाएगा. 1 और 2 के बीच में तो 2 पे जाएगा, 1 और 0 के बीच में तो 1 पे आएगा, 0 और minus 1 के बीच में तो 0 पे आएगा, minus 1 minus 2 के बीच में तो minus 1 पे आएगा. तो let's do it. Very simple. Let's write it. Y is equal to fx equal to this way, and then let's start writing. From अगर ये 0 और minus 1 के बीच में है, 0 और minus 1 के बीच में है तो minus 0 देगा. अगर ये -1 और 2 के बीच में है, -2 के बीच में है तो -1 देगा. अब उल्टा देगा, देखो यहाँ पे आएगा. Let me repeat it in English. Between -1 and 0 it will give you 0. Between -2 and -1 it will give you -1. See, between 0 and -1, between this it will always go to 0. So this has come. Now between -1 and -2, between -1 and -2, it will go to -1. That has got. Now between 0 and 1, between 0 and sorry, let me rub. Wait a minute. Let me rub this. Yes, between 0 and plus 1. 0 and plus 1, between 0 and plus 1, it will give you 1 here. It will give you 1. Between 2 and 1, it will give you 2. This is the way it is. And its direction is just, see one thing. Compare this and compare this. These two. It's just the opposite of each other. So, ये दोनों एक दूसरे का अपोजिट है. मुंह इसका इस तरफ है ना, मुंह इसका इस तरफ है. अब मुंह उलट जाएगा. इसका face will change on the other side. Face will go on the other side. That means I mean to say the face is on this side. The face is on this side. Now the face will be opposite. That's what I want to say. Now see how it is. How it is. Now see how it is. Let me draw the graph here. This way. This way. Let me take 0. Let me take 0. Then let me take 1. Then let me take 2. Then let me take -1 and -2. No problem. If I take this, this is my x-axis and this is my y-axis as usual. Now between -1 and 0, between these two, it is always 0. So it will 0, but it is never -1. So let me change the color and draw. It is never -1. I have drawn it. Now between -2 and -1, it is -1. It is -1, but never -2. So you will draw like this, and this is never -2, but this one, and this point is -1. And let me draw this point here. This is 1, and this is my 2. I think I'm drawing in the opposite side. No problem. No problem. Let me draw it. If I need, then I'll change this. Now up 0 or now between 0 and 1. Between 0 and 1, it is 1. It is never 0. So draw like this, and 1. 1 is this point. 0 और 1 के बीच में 1 है. 1 तो नहीं है ना, तो 1 के यहाँ पे ऐसे बनाना है, सीधा एक लाइन खींचना है. अब between 1 and 2, it is 2, but never 1. So this will be like this and never 1. I hope never 1. ये 2 तो बन गया ना यहाँ पे. It has become 2, but it is never 1. So अब समझ में आ गया होगा. 1 और 2 के बीच में है तो 2 को छोड़ देना है 2 के सामने और 2 तक जाना है. 1 तो नहीं जा रहा है ना, 2 पे जा रहा है. तो 1 का ये पोर्शन छोड़ देना है और 2 वाला पोर्शन को डॉट कर लेना है ऐसे करके, जैसे कि 2 को इंक्लूड कर लेना. देखो इसका डायरेक्शन उल्टा है. आई थिंक नाउ यू अंडरस्टूड द डायरेक्शन ऑफ द फेस इज ऑपोजिट नाउ. This is a very, very important function, these two. Another two I will do, they are also very good function. They will help you to solve limit and continuity and differentiability very easily. Stop the video and copy slowly. Understand, if needed, repeat it. That's why I'm trying to repeat things, repeat words also. Acha, now let me take it a little more down. Yes. Wait a minute. Wait a minute. Yes, here it is. Now let me draw this. Now we have this. Now we have this function known as fractional part of x, known as fractional part of x. 16th, 17th function. This is the problem with me. I always forget which function I'm talking, which number I'm talking about. 15, this is 16, yeah, I'm talking about 17 now. This is 17th function, and this is known as fractional part of a function. Fractional part of a function. इसको fractional part of a function बोला जाता है, and it is denoted like this: y equal to x minus greatest integer function x. Greatest integer function x. See, now I will make you understand how to do this. Now you draw this ladder again. You draw these two ladders. Draw it. Draw the ladders properly. Draw the ladder. This is 0, 1, and this is 2. And this is minus 1, minus 2. So since this is a greatest integer function or the floor function, let me call floor function, it will be easy. Any point, कोई भी point इसके बीच में will come here. Any point between 1 and 2 will come to 1. Any point between 1 and 0 will come to 0. Any point between 0 and minus 1 will come to minus 1. Any point between minus 1 and minus 2 will come to minus 2. This is the way it is. Take example. Take x equal to 1.5. So see, y equal to 1.5 minus greatest in floor function 1.5. 1.5 कहाँ पे जाएगा? 1.5 2 और 1 के बीच में है, तो 1 पे आएगा. 1.5 is in between 1 and 2, so it will come to 1 because of this floor function. So this you will get as 1.5 minus 1 and you'll get 0.5. I hope you understood. ये समझ में आया है. अब let us take x equal to 0.1. So y is equal to 0.1 minus greatest integer floor function 0.1. 0 और 1 के बीच में, 0 और 1 के बीच में फंक्शन कहाँ पे आ रहा है? 0 पे आ रहा है ना. तो 0.1 minus 0, क्योंकि 0 पे आ रहा है, यहाँ पे देखो, see here it is coming to 0 because it is this is a floor function, so answer is 0.1. I hope you have understood. Now take x equal to minus 0.5, y equal to, you write, wait, use this formula, write 0.5 minus 0.5, sorry, wait, let me rewrite, wait a minute, minus 0.5 minus bracket minus 0.5 floor function. Minus 5, 0 और minus 1 के बीच में आता है. Minus 5 comes between, minus 0.5 comes between 0 and minus 1. So you write minus 0.5 minus, this will come out to be, put a normal bracket now. This will come out to be minus 1, put a minus 1. Now minus 0.5 plus 1 will give me 0.5. Again positive value. See, it is always between 0 and 1, 0 and 1. Now let me take another value. Let me take another value here. Let me take y equal to 2, x equal to 2. Now let me take x equal to 2. What happens? Y equal to 2 minus greater than 0 function 2, and you get 2 minus 2 and you get 0. अगर मैंने x equal to 2 लिया, you will have to put 2 minus 2, and greater than floor function of 2 is 2 only, and 2 minus 2 is 0. So ये function 0 और 1 के बीच में लाई करता है. 1 भी नहीं होता है, 0 तो हो सकता है, परंतु 1 नहीं हो सकता है किसी भी हालत में. It can, see, let me repeat in English. This function can always become 0 but never 1. This function can always become 0 but never 1. So the graph of this function is somewhat like this. Let's see the graph of this function. This is a very, very important function while trying to find limit, continuity and all that, and differentiability. Wait, let me keep it in your video for some. Here. Now I hope you have understood. This is a very, very important function, and keep it in your mind. Now let's come down and draw the graph. I don't know what is happening. Yes, now let's draw the graph. Now this is your x-axis. This is your y-axis. This is your x-axis. I said this always lies between 0 and 1. So only 1, y equal to 1 is this line. ये 1 और 0 के बीच में ये y equal to 0 वाला line है. That is x axis. That is y equal to 0, x axis. Now at 0 it is 0, and between 0 and 1 it is always, it never reaches 1. So draw the line and never touches this line 1. This is 0. Now let's take the example of 1. So if I take 1, so what I'll get this type of a thing. At 2, I'll get this type of a thing. Now let's see in the minus side. Minus 1, you will get like this. It will never reach to 1. Again at minus 2, it will never reach at minus 1. This is the way it is. See, at 0 it will not reach 1, at 1 it will not reach 2, at 2 it will not reach 3, minus 1 it will not reach to 0, minus 2 will not reach to minus 1. That's the point. This is the way this line has to be drawn. This is the graph of this function. Now the fractional part of the function is given as x minus floor function. Let me call it floor function. Now let's draw this ladder. Let's write here the numbers 0, 1, 2, minus 1, minus 2. Now for any function fx equal to, let's make this. Now see, for x between 0 and 1, अगर x 0 और 1 के बीच में है तो it will go towards 0. If the number is between 0 and 1, it will go to 0 for this floor function. Floor function के लिए अगर number 0 और 1 के बीच में है, it will go to 0, and this is any value x. Now you can see here, you can see in this, I have done one example. You can see the example. This example I'm talking about, this one. This example I'm talking about. See, this number is between 0 and 1. So it is that same number. It is the same number because this quantity has become here 0. अगर हम एक नंबर लेते हैं 0 और 1 के बीच में, जो नंबर जो वैल्यू आएगा वही वैल्यू आएगा जो नंबर हमने लिया है. x हमने क्या लिया है यहाँ पे 0.1, तो हमारा वैल्यू भी आया है 0.1, बिकॉज ये जो फ्लोर फंक्शन है ये वैल्यू देगा 0. Now the number we have taken is 0.1, and since this is the floor function, this floor function will give the value 0, so I'll get the same number 0.1. I hope you have understood this. So here in this case it will be x. Now between 1 and x between 1 and 2, between 1 and 2, एक और 2 के बीच में अगर नंबर है तो वो एक में आएगा. Between 1 and 2, if the number is between 1 and 2, the floor function, this floor function will give 1, and this is x as it is, so it will become x minus 1. Now you go to some number, let us say 2 to 3. Let us take a number 2 to 3. If I take any number here, it will come to this floor function. So between 2 to 3, it will give me x minus 2. Because ये जो floor function है, because this floor function will come to 2 here, it will come here. The floor function will come here. Now, if a number is in between 0 and minus 1, so it will give me minus 1. So the floor function will give me minus 1. Let me rub this. Yes, this floor function will give me minus 1. So x minus of minus 1, that will be, so let me now rub it. This will give me x plus 1. This will give me x plus 1 for x less than 0, greater than minus 1. Next, less than minus 1, greater than equal to minus 2. That is between this and this. It will give me, if the number is between minus 1 and minus 2, the floor function, this floor function will give me minus 2. So this minus will make it plus 2. So it will be x plus 2. अगर नंबर एक माइनस 1 और माइनस 2 के बीच में है तो फ्लोर फंक्शन माइनस 2 देगा, और माइनस यहाँ पे ऑलरेडी है तो माइनस माइनस विल बिकम प्लस, सो इट विल बिकम x plus 2.